Hello, welcome to Enots Engineering. I'm Alan. Today we're back in the workshop and I've just noticed just outside the door are some blue tips in the nest box. So what I'm going to do today is check the tailstock alignment and see if I can figure out how to do that without a ground bar, and some of the problems you may have if you use a ball point on the dial indicator rather than a flat. But let's have a look at the lathe and see how we can measure if the tailstock is out of alignment with the headstock. We start by making a simple test bar in the lathe. A little lower. I don't know whether you can see it on my lathe, but what I've done is on this adjustable nut here that hires and lowers your tool, I've actually scratched a line which is there, and that's useful for when you're trying to adjust a tool to the height. If you use a favourite tool all the time, you'll know roughly where it's set. With that line you can use it as an indicator to know when you've got the tool set on the right position. So I'll face that off. What I want to do now is turn about 1/2 inch along. There's no need to waste material because I can use this bar for something else afterwards. Just clean the diameter up about 1/2 inch along and then try and get a really good finish on it. I've cleaned it up. When adjusting your tool you can use the white plastic that I have underneath just to make sure you've got the right contact position. So what I have there now, if I back the tool off, you can just see the tool is nearly parallel with the metal. So as I take a cut, I should get a better finish. Because the tool is, rather than cutting into it too much, it's more polishing it. So let's see how that looks. Yeah, that's quite a nice finish. So now I'll use my emery stick just to polish the last bit. And you can see the finish is okay. So what I'm doing now is going to turn it round, face the other end and centre drill it. So now I'm removing the chuck. Clean. And another centre in the tailstock. I've just got this piece of aluminium angle, drilled a hole in it, 6mm cap head and a 6mm nut. That holds the dial indicator. This dial indicator is in 1/10 of a thou. It must get the centre of this on the centre line. So by putting this angle in the tool post, it's dropped the dial indicator down so it'll be on centre line. Also you need a flat anvil on your dial indicator. That's important and I'll tell you why in a minute. take the bar and put it between the centres. I've just checked that the tailstock is set to 0 and it's got some marks on the back. This is the reason why you use a flat and not a domed end to your dial indicator. So you can set that on centre, 0 your dial indicator. You move down to your tailstock, and because your tailstock is lower, your dial indicator is no longer on centre. So what you're doing is setting your tailstock to bring the bar parallel when you could be above. You most likely be above because the tailstock's usually worn and falls lower. So you're putting an error in there, you're putting a taper in, thinking that your tailstock is parallel, but you've actually put a slight taper. And depending on how low your tailstock is to the headstock, that taper will be worse. So by using a flat anvil on your dial indicator, it will pick up the highest point either end and give you a true reading of the tailstock error. Once you've set your dial indicator on centre line and square, put your bar in, your test bar, just nip it with the tailstock so you can still turn it. Wind your cross slide in and line it up so that your dial indicator is virtually just on the edge of the bar. Wind it in. I'll go in 1 revolution. Turn your bar around to get the lowest reading. This is nearly a thou run out on this, so it's there. And turn it round, turn your cross slide round, your top slide till you get it to 0. Now I've set that dial indicator 1 revolution at 0. So undo your tailstock, just unscrew the quill, but I'm leaving the tailstock clamped, and then move your saddle down to the other end. Put your test bar in the other way. Just bring your tailstock in. Move your dial indicator back to the same position. Rotate the bar to get the lowest reading, which is there. As you can see, I'm 1, 2, 3 thou, say 3.5 thou out, which means 3.5 thou over 11 inches. That's close enough for me. If for something specific I'd want to get exactly right, I would alter it to suit what I was doing at the time. So we've checked the offset in that axis, but what also we need to know is how far out it is up and down. Now you can assume that your headstock is right because I don't think there are many lathes where the headstock actually moves. So that headstock has probably not moved since the machine was made. So the slide underneath is not worn and it's been bolted there for 40 odd years. It's the tailstock that's been sliding in and out. The tailstock will be worn on the bottom where it runs along the bed. So to check that, we remove the dial indicator. Then put the magnetic base on the cross slide. It's not critical on the top because you're using your cross slide to come across the top. That's why you can use a round stylus to your indicator on the top. Because as you come across, you're picking the highest point up, and as you do it on the headstock end, you're picking the highest point up. Okay, bring the dial indicator in, get the highest reading, rotate your bar till you get the lowest reading, and set your dial indicator to 0. You can now move your dial indicator off the bar, under the bar without moving the tailstock clamp. Turn the bar around the other way. Move the carriage down to the other end. Bring the dial indicator back in over the test piece to get the highest reading, and turn your bar to get the lowest reading. And looking at that, we are 2.5 thou out. That's telling me at 2.5 thou that the headstock is 2.5 thou higher than the tailstock. So that should show wear on the bottom of that tailstock. On this lathe, if you need to adjust the tailstock, you can slacken or tighten the screw up that's on a slide to bring the tailstock forward or backwards to line it true. Oh well, I hope you found that interesting and hope to see you on the next episode of Enots Engineering.